This is a quick spin around my CBUS Test module board. Basically what we're looking at here is one end of the CBUS bus. The connector on the top of that CAN ACE3 module, basically it's a connector going straight into a female connector with a resistor on the bottom of it to terminate the bus. And then that goes into the module. CAN ACE3 can take, I think it's 128 switches on it. It's meant for use on a panel. And yeah, there's 32 on-off switches arranged in pairs of on and off. The row of column switches there that's empty, you can put switches on there that are just, you flick them on and they stay on. But I chose to just do the push buttons, which is more useful for a panel. Okay, the next module here is a CAN AC8. It's an 8 output device, and I've got 8 LEDs connected to the outside of it. It listens for events and sets its outputs based on the events it's been taught to listen to. So what the 3 LEDs at the moment is showing the position of, well, the left one is a tortoise, the right one is the first servo, and the centre one is the second servo. Down here we have a CAN ACE3, which is another input module. And the reason there's 2 here is so that I can use what are called short events. That allows me to generate the same event from several places. I could generate it from my PC, I could generate it from multiple CAN ACE3s, so that you could actually have 2 modules, 2 panels the same or overlapping with the same controls on there, and either operator could use them. Very good idea. And it means that you don't have to program all the other devices to listen to unique events from each device. Basically the events are source independent. Yep, this layout uses Moo. Good on you. Up here is a CAN AC5. This module is running the tortoise that's there. There's a loop of purple and green wire there, which is one set of wires to one switch, and the other lot of wires goes up to the module above. We'll get to in a sec, the CAN ACE8C. Over here is a CAN USB. That device is used for connecting back to the computer, and it can keep up with the full frame rate of the CBUS. Next up here we have a CAN RS, and no, it doesn't mean what RS usually means. It means it's a serial to computer board. I use it so that I can connect the board to JMRI and to the FLIM configuration utility at the same time. That way, as I configure the board, I can have JMRI learn the events at the same time. Saves a bit of mucking around. The 8C, its job is to listen for events, so it's plugged into the switch on the top of the tortoise, and it's responsible for detecting where the tortoise is, so that I set one of those lights that you saw earlier. One of the things I didn't say is the CAN AC5 down here. Basically all of the inputs the outputs are independent. But to run a tortoise, basically when an event comes in, you set one output high and the other low. When the off state for the event comes through, it actually just does the thing the other way around, so the tortoise just goes to the other end. That block there doesn't have to be there. It's there so that I can basically unplug that 8C module without having to unscrew anything. The little device up there, basically it's just a 5-volt regulator, because these 3 modules you can see here, they are all 5-volt modules, whereas the rest of them are all running on 13.8 volts. This is a CAN LED. It's meant for use on as a panel driver, so that you use a CAN ACE3 and a CAN LED, and you can put the lights all over your panel and put the switches all over your panel. It'll run 64 LEDs, which is what's on that board there. Originally I was going to put the board down on that LED board down on the board here, but I didn't. I just plugged it straight in the top, and as a result the 4 aspect signals I was simulating are upside down. I may well still get a little ribbon cable and put it down on the board so that it's the right way up, or I might even just make another one. Down here with another terminator, so it's obviously the other end of things, is a CAN servo. It's a CAN servo 8C, so it'll run up to 8 servos. I've got 2 connected in servos 1 and 2, and it will generate events to say whether the servo's at one end of its travel, the other end of its travel, or in the middle. Pretty useful device. So the way I've got it set up at the moment is when I press one of the push buttons, servo 1 moves, then servo 2 moves. When servo 2 moves to end of travel, an event's generated and it's picked up by the CANAC 5 here, and it tells us the tortoise to move. And when the tortoise has moved to the end of its travel, it sends an event. And over here, what happens is for the end of travel of each of the servos and for the tortoise, the lights indicate where they are. So right now I'm going to press one of the switches and we'll see what happens to the lights. There's servos 1's moved, servo 2's moved, and now the tortoise has moved. And I'll press the off of the same thing and away it'll all go. And just to show you that there's more happening than just the lights, I'll back off a bit so we can see all of the bits. Yeah, we can't see it all, but I'll look at the servos and the lights, and unfortunately we're getting whited out because of the, there we go. So you can see the servos go. You can't see the tortoise go, but it did. Just to do that again so you see those two bits, I'll come over here. Yeah, I know you're getting seasick. I am too, trying to do this and hold it. Okay. You heard the servos go and you saw the tortoise go. And there's the lights. All done.